Hi everyone, welcome to my channel. If you're new to this channel, kindly subscribe and hit that notification button to always get my updates. Today's tutorial will talk about tuples, or tuple or tuple, whatever you may call it, but as long as you know what it means and how to treat it in Python. Alright, so the objective of this tutorial is to look at how do we create a tuple, what is a tuple, how we can access different elements within a tuple, how we can do tuple slicing as like applied it to lists. If you haven't watched the full video for the list, please go ahead and do that. We can see how we can delete a tuple, or we can delete some of the items within a tuple, and how we can go ahead and reassign elements within a tuple. Alright, and then we can again see what it means by immutable. We'll look at also the most common functions within tuples. We'll also go ahead to look at the index and then the count as applied to tuple. And then finally we'll try to look at the membership and the concatenation as applied to tuple. Alright, so basically what is a tuple? A tuple is a given data type that is created by using two parentheses. Alright, so let's see what it means by that in a given example right here. So let's say t equals, we have two parentheses, alright, and then we have two numbers 1, 2, 4, and then 5. Let's try to check what's the data type for t. By checking the type of this data t, that will give us a tuple. Alright, so this means that whenever you're creating a tuple, or you're interested in creating a tuple, you have to use these two parentheses. Another way to do this is to use just items listed by or separated by commas. For example, 1, 2, 3, and then 5. If we check the type of this data that is assigned to capital T, it will give you a tuple. So these are the two main ways how we can create a tuple. Alright, so let's see. All we know is that tuples are immutable. Alright, that's the first thing we all know, that tuples are immutable. What does this mean as applied to tuples? Being immutable, it means that we cannot change them, we cannot change their structure. Alright, so but in some ways there are some limitations and conditions how we can change actually tuples. Alright, how we can change them and so on. So let's first of all see what immutable means as applied to tuples. So let's try to recall our t above, which is 1, 2, 4, and 5. Let me say, for example, I want to change a 4 in this tuple, and I want to reassign it to 3. Then I need to first of all access the number I need to change or to edit, and that means I have to index that number, which is in the third position. That means we have to index it with 2. Remember, Python begins from 0, 0, 1, 2. Alright, and that number, first of all, if we try to access it, that is 4, which we exactly need. So that means in the third position, that is equal to, let's say we want to assign it to 3. Alright, and then we call back t. If we do that, it will give us an error. So this is just as a reminder, like we did before in the previous videos. So this means that you cannot edit anything within a tuple, but like I mentioned already, it has some limitations that we can quickly look at here. So in other words, you cannot remove this 4 to assign it to a 3. But if this tuple contains maybe lists and so on, then it is possible to change that tuple. That is one of the features that makes it maybe weak. Let's say what happens, right, if a tuple contains a list. Alright, just like lists, tuples can contain anything. It may be a float number, it may be an integer or anything. Let's say n equals 1 to 0.5, which is a float. It has a string, maybe t, alright, and then it contains a list here, right here, which is 1, 2 of 3. So let's see what happens if I run the type of n. It will tell us this is a tuple. But let's see what happens if you want to access this element here, which is now a list considered as one element within this tuple. Let's see what happens if I want to change it. So I'll simply say access that number, that list element, which is in the 0, 1, 2, 3, and then 4. It is in the 4th position. If I access that, which is a list, all right. So what happens in that case? If I want to change it, then I can say n of 4. Then let's say the second element, that is index 1, is equal to 6. All right. So then if I go back down and update my n, it will tell me that this has been changed. So this tells you that this tuple n has been changed. Definitely it's no longer the same as before, as you can see. So these are some of the limitations how a tuple can be changed. All right. So but if I wanted just to remove only a full item like this, then it will not allow me to remove a full list of that, or to replace it. It would not allow me to go ahead and do that. So far we have seen what is a tuple, how we create a tuple, and now let's go ahead to see how we can unpack tuples. So let me recall my small tuple t again, which has elements 1, 2, 4, and then 5. If I want to unpack these ones, there are 4 elements within this. I can maybe say each element I let it be a certain variable or letter, a, b, c, and then d, and that is equal to t. If I go ahead to run this, all right, so this means that for each of the elements within this tuple t has been assigned to any of these ones. So for example, if I run a, that will give me 1. If I run b, it will give me 2, and so on and so on. That is called unpacking, all right, in terms of tuple. So in other ones, you have assigned each of these inside elements to be equal to any of these variables a, b, c, and d. All right, so that is what we call unpacking. Let's try to look at slicing. All right, that is tuple slicing. Just like lists, we can slice tuples. All right. So again, in the same way, we can make a use of this colon, and we can slice it both in the positive and using positive and negative indexing. Another way to create tuple is by using just the word tuple. All right. Range of maybe some numbers from 0 up to maybe 20. All right. So if I go ahead and print L, let's see what it gives us. It gives us all the numbers between 0 and then 20. We have already seen this function range, that it gives you all the numbers from that starting number to the last number minus 1. All right, so which you can see that it goes up to 20. So now we have our tuple L. Now let's look at how we can begin slicing. Like we already mentioned, when you're slicing, you use these square brackets. And the first thing, if you want to access all the elements, then you can just use a colon, and that will access all the elements. Now let's try to see if you want to access maybe from some number to until the end. Then you can say tuple from maybe the fourth the number that is in the 5th position, which has index 4, up to the end of the tuple. Then that will give you from this number 4, the number that is in the 5th position, because this index 4 refers to the 5th position, because Python begins from 0, so that would be 0 1 2 3 0 1 2 3 4. Alright, so that's how you can access all the elements. Now let's say we need to access the 5th number. So that means we have index 4, which is accessing the 5th number until maybe till the end. If I run that, that will give me from 4, which is the 5th number, right, until the end. Okay, that's what it means. Now let's say we need to access all the elements from at the beginning until some number, maybe in the middle or towards the end. I can simply say again, I consider all the elements, I consider all the first elements until maybe the 14th. But again, remember, Python stops at 1 minus less, at that I mean 1 less that number. So when we do that, it will give us the number in the 13th position, right? So that means it starts from 0 1 2 3 and so on until the 13th, so it will not reach the 14th term, right? The 14th position. So these indexes are referring to the positions. Alright, so that's how we can try to slice numbers. And alright, so let's try to see if we can reverse a tuple, just like lists. In list, when you're reversing a tuple, we simply use double colon and then -1. Alright, this reverses the list, but let's see if it is applicable to even tuples. If I do that and then run tuple the L again, it will not do that. Alright, let's try to use another function which we know that can as well reverse. If run L dot reverse, alright, just in the same way we can run in for lists. If we do that, it will tell us object has no attribute reverse. But let's say if it was maybe a list, and this is 1 2 3 and then 4, alright, and then we run y dot reverse. Alright, so this would give us a new y, which is 4 3 2 1. Alright, and again, let's see if we wanted to reverse it in the other way, semicolon and then -1, and then this would give us again a reversed way. Alright, so these two functions, as you can see, they don't apply to a tuple. So tuples cannot be reversed. In other words, that's what we just looked at as being immutable, because it's like you're changing this number to the first position, this one to that, which is impossible. Alright, so even this one of slicing and reversing all the terms or all the elements cannot be applied to tuple, because it's like you're removing this number, assigning it to this one, and so on and so on. Alright, so finally we can look at some of the negative indexes. We can look at the negative indexes, and we say L. Alright, let's try to run it again, which is that, and then let's say we have L from minus say 10 to minus maybe 3. Remember, when you are looking at minus indices, we are looking at the last one as being -1, -2, -3. Alright, so that is in the 17th position, and then -3, -4, 5, 6, 7, 8, 9, 10, -10 until somewhere here. So let's try to see what it gives us. So -10, like I said, it's right here, and then it goes until somewhere here. Alright, so because this is -3, it will not stop there, so it will stop at -4, because we know Python stops at one number less to the to its upper limit. All right, so that is why it is stopping at that, and so that is how we can use minus indexes. All right, so this is how we can deal with the tuples in terms of slicing and so on. Now let's try to look at how we can reassign. Reassigning, we have already basically looked at how we can reassign items in tuples, and we said it's impossible because it's immutable. For example, element in the 5th position being equal to maybe 20, and if we do that and we call back L, that will tell us it does not support item assignment, just because it's not it's not mutable. In other words, it's immutable. Now let's look at if we wanted to delete a tuple, we would use just again in the same way. We cannot delete terms. All right, we cannot delete these terms. For example, if I say I'm deleting terms of L from maybe 0 to maybe 0 to 4, we cannot do that because it does not support editing or altering those elements within from 0, 1, 2, and then 3. It cannot do that, delete, because it's immutable. All right, for the case of a list, for example this one, let's give an example like already y, which you have used. If we say delete y and you specify the elements, we need to delete maybe element in the 2nd position, and then we finally call back our y. It will tell you 4, 2, 1. All right, but remember y was 4, 3, 2, 1. All right, so this gives you that 3 has been deleted, which is in the 2nd position. All right, so that means let's support this deleting of items within them, unlike the tuples. All right, so let's continue with deleting. Let's say we need to delete L, the whole of it, and then finally we try to call L again. What happens? It will tell us L is not defined. Why? Because the entire tuple has been deleted. All right, so if you are trying to delete the entire everything from the memory, from the computer's memory, you can delete the entire tuple, but you cannot just delete some of the elements within a tuple. All right, so I think this is well explained, and then let's try to look at just some of the most common functions within tuple, the basic ones. Of course, there are several functions that can be applied, but let's try to look at the most common ones. And I will begin by creating my my tuple, a new tuple, maybe 0, 3, 5, 7, and 9, and then 10. All right, and then when we come here, if you want to know the length, just like in lists, we can say m. All right, and then if we run that, that will give us 6. Remember, that gives you all the elements, the number of elements that are within that tuple, that is 6. And then if you wanted to know what's the maximum number or maximum element within this tuple, then we would simply say, we can simply say maximum of, what is the maximum of m, and then it will tell us it's 10. And then if you wanted to know the minimum, we would simply say minimum in tuple n, which is a 0. All right, and then if you wanted to sum up all the elements, I'm assuming they are of the same type, like for example all numerical, let's say float, integers, and so on, without maybe a mixture of string. We can usually sum all that up quickly without any issue. So in that case, we would simply say sum up m, and then that will return the sum of all those elements. Alright, so how about if these numbers they were in kind of an unorganized way? Let's say maybe we have 2 minus 1, maybe 10, alright, and then we have 5, and then we have 3, alright, and then we wanted to sort these numbers quickly to have them uniform. We can say sorted dot sorted k, and then if I run that, it will sort it out and then return for us a sorted list of numbers. And if I wanted to have it back in terms of a tuple, then I can say tuple of a sorted k, so that it doesn't return just the list, so that it returns a sorted tuple. Alright, so let's look at how we can usually convert basically a tuple into a list. That is simple. We can do that by using just the list or a tuple. Those two functions, they can always change our data, interchange our data into the other. Let's say we have alright, our tuple k. Let's say I want to have it in terms of a list. Then I'll simply say maybe list z is equal to list of this tuple, which is k, and then if I call down z, it will simply give me this one as a list. Alright, and then if it was a list and I want to have it as a tuple, then I would simply say c, which is a tuple that I want. I'll simply say tuple of z. We know that now z is a list. Then I'll simply convert that back to a tuple. If I call that back again, it will give me a tuple. Alright, so you can interchange from one data type to the other just using these direct functions, list and tuple themselves. Now let's try to look at briefly how you can tell the index, or using the index, and mention maybe the position of the number. For example, again I'm looking at k, a capital K. If I call it back again, it's minus that and so on. If I say k dot index, alright, and then I put the index, I want to know the index of number 10, alright, and then say that, and then run that, it will give me 2. Alright, I'm trying to produce the index of this number here. For example, let's say this is 0, 1, and then 2. This will throw back the index of 10. What's the index of 10? Is 2. But now this is only going to be possible for the first occurrence. Let's say we have several occurrences, like we have 2, 3, 5, 6, 5, 7, and then 5. Alright, now in this case I want to show you that if there are several occurrences of a certain number, this function .index will only return the index of the first occurrence. So let's say d.index of 5. Alright, so if I run that, it will return only the index of this first 5. That gives me 2, because the first 5 occurs in position 2, 0, 1, and then 2. So we have to be careful when you're trying to access one or either number if there are many occurrences. How about the count? The count simply gives you the how many or the occurrences of those numbers. Let's say d dot count of 5. We want to count how many numbers, how many 5s do exist within this tuple. It will tell us there are 5 because we have already 1 here, 2, and then 3. So that is how basically you can use the index count functions in telling us about something to do with our tuple, the information in our tuple. Now let's look at we have already now created our tuples D, all right, and then we have also our tuple K right here. Now let's see how we can look at membership, and then we can say look at concatenation. And then so for membership, in this way we mean for example, if we have an element that exists in D and also exists in K. So let's say if we want to check all numbers or to print all numbers that exists in K, and they can be found also in D. So you can simply write a simple for loop for J in K, all right, and then you can put a condition that if J is in D, all right, then print J. Let's try to keep it this way. If I run that, it will tell me we have 2, 5, and 3. Let's check that. First of all, we see we have 2, all right, which is in K, and it happens so that it is also in D. We also have a next number. This doesn't appear. We also have 5 because we are scanning within K, which appears in D. And then finally we have also a 3 which appears also in D, and these are the numbers we have. All right, so if we wanted to make it just another list, we could say like appear, and then we have that as an empty list, and then we can come maybe down here and say appear. I know this is not a good naming. Dot append J, all right, and then finally we print appear, which is our empty list now, which is our new list, which is 2, 5, and then 3. All right, so this is how you can look at kind of membership for this one, in that, and so on. I know there are several ways of writing this, just even in one step. All right, so let's look at how we can do concatenation in tuples. Remember, concatenation is like joining two things together. That's the basic way of understanding that. All right, so let's perform some concatenation here on the two tuples, and let's say f equals our two tuples D and K plus D, and then we call back if and see what it returns to us. So when you look at this, you can see that we have added K, which is starting from 2 up to 5, 2 up to 3, which is this one, and then you have added on D, which begins from 2 up to 5. All right, so we have now formed another new tuple of length, the sum of this and sum of that. All right, which is of length now 12, which is the sum of the other one and the sum of this. All right, the other one is 7 and this one is 5, so that takes us to 12. So how about can we perform iterations on a tuple? Yes, let's say in a quick example here, we have, for example, for I in F. All right, let's say we want to perform some operation, and we square all the numbers in this F. We can say print maybe I squared. All right, so if I do that, so I'm iterating through all these numbers I and squaring them. If I wanted again to store them back to another tuple, then I'll do the same thing by storing, or storing them in one or let's say we want to keep them in a list, I would just say either one way to create this empty list, and then we begin appending h dot append manually I squared. All right, I squared, and then finally we can print out our h like this. So this prints out our I squareds by iterating through all these elements in I. Alright, so this has been done in 4 lines, but the same thing can be done just within 1 line of code. If we create our list and we say I squared, alright, for I in F. Alright, just one code, and simple as this. If we run that, it will give us 4i and so on. So let's try to look at nested tuples. So what are nested tuples? Or what does it mean when we say something is nested or a list is nested? This simply means that we have a list under a list or a tuple under tuples. For example, if I call it nt nested tuple and it's equal to 1 tuple, and then within this tuple we have 1, 2, 3, and then we have another tuple again within 0, -1, and then 3. Alright, and then finally we have another tuple which is -3, -5, and -8. Alright, so again when you check this, the type of this data of nt, we get a tuple. So in the same way we've been doing for the rest of the tuples is the same way we can do this, only that in this case it may differ a little bit. For example, like if I wanted to access this element here, this element still is considered as being in in the second position with index 1. For example, if we say nt of 1, we'll get 0 -3 minus that. So if I wanted to access one of these elements within the second element, then I would simply say n of t, then in the second position with index 1, and then second element with index 1. That will give us -1, and this is what we have. So you can see that in this case, if I wanted to assign that number to something different, maybe to 20, it will not allow, because even what is inside is a tuple. Alright, so which has a feature that, or characteristic that it cannot be changed. Thank you guys for watching. Kindly subscribe and hit that notification button to always get my updates on each and every video that I'll be posting.